Hello everyone. Today Chemistry Tute is again back with a very important session of the only numerical chapter which is there in semester 2 ISC, that is your chemical kinetics. Today we will discuss certain important formulae with which are related to this chapter. Apart from these formulae, I will be discussing at least one board question which will give you an idea that how you can apply the formula. So without wasting any time, just let me share the screen with you all. So here it goes. Now here you can see the important formulae of chemical kinetics. The rest you are well aware with my introduction. I don't require to give again and again. It's only for the new subscribers who don't know. It's for them. So let's start with the first one. That is your half-life period of a first order reaction. Now this order of reaction, it can be zero order, it can be first order, second order, third order, and so on. What is this order of reaction? When you all write the rate law equation, your concentration term is raised to the stoichiometric coefficient. It raised to the power of stoichiometric coefficient. That represents the order of reaction. And when you sum up these order of reaction, you come to know that what is the overall order of the reaction. Now, in this, when we say half-life period, your T half represents the half-life period of a first order reaction, where it says that T half is equal to 0.693 divided by K. Your K is a rate constant. Unit is very, very important. Please do not forget to input the units. Now, in this case, the rate constant for first order reaction is per time. If your time is given in seconds, it will be per second. If it is given in hours, it will be per hour. If it is in minutes, it will be per minute, and so on. Then comes the next one, and that is the integrated rate expression for the first order reaction. Now, what is this integrated form of first order reaction, children? The formula says K is equal to 2.303 divided by T log A into A minus X, where A is the initial concentration and A minus X is the concentration after time T. Again, this is something very important where you have to input the values and you can calculate either time or the rate constant. Whatever is the subject of the question, you can use the formula for that particular purpose. Then comes the next important formula, or you can say the next important topic of this particular chapter, and that is your Arrhenius equation. Now, this Arrhenius equation, the significance lies in the information. It gives a quantitative relationship between the rate constant and the temperature. The equation says your K is equal to AE raised to the power minus EA divided by RT, where K is the rate constant, which we have already discussed. A is the frequency factor. E is Boltzmann constant. EA is your activation energy. R is the gas constant and T is the temperature in Kelvin scale. Then comes the next one, the graphical representation of activation energy. We are very well aware with this term. Now in this graphical representation, your log K is plotted on the x-axis, 1 by T is plotted on the y, as you can see the graph. Your slope is minus EA divided by 2.303 into R. Now, in this, the other way around, to calculate your activation energy, the formula says log K2 upon K1 is equal to EA divided by 2.303 R into 1 upon T1 minus 1 upon T2. Then comes the next. These are the examples which I have gathered for you all, certain important board questions. Your first example is from 2013 board question, which says, in a first order reaction, 10% of the reactant is consumed in 25 minutes. Calculate the first part, the half-life period of the reaction. The second part says the time required for completing 17% of the reaction. Now here you have to understand that your form K will remain constant for that particular reaction, whether it is 50% complete, it is 70% complete, it is 17% complete, it is 99% complete. So with the first calculation, when we start, your T half is equal to 0.693 divided by K. We don't know what is the value of K. So we will use the first information given in the question and calculate the value of K. Now, when we discuss about semester 2 examination, it is a subjective examination where step marking will be very, very important. So in the numerical, your marks are divided into steps where you get mark for writing the formula, showing the substitution, then comes the final answer, and then comes its unit. So accordingly, the marks are divided. So when we input the values, your value of K is coming as 4.215 into 10 to the power minus 3 per minute. So you will substitute this value for calculating T half. So your T half will be 164.41 minutes. The second part says the time required for completing 17% of the reaction. So in the formula, again, you will write the formula. T is equal to 2.303 divided by K log A upon A minus X. K will remain the same as I have already discussed. So your time will be 44.21 minutes. I hope this gives you an idea how to use the formula for the application purpose. Then comes the next example, which is from 2020 board question. A first order reaction is 50% completed in 30 minutes at 300 Kelvin, in 10 minutes at 320 Kelvin. Calculate the activation energy of the reaction. Your R will be given in the question. You have to quote that particular value of R. Here it says 8.314 joules per Kelvin per mole. So your K1 is equal to 0.693 divided by T half. Similarly, you will calculate K2 and then you will use the Arrhenius equation, which says log K2 upon K1 is equal to EA divided by 2.303 R into 1 upon T1 minus 1 upon T2. Because it is a first order reaction which is 50% completed, that is why we have used the formula K is equal to 0.693 divided by T half to calculate the respective values of K. On substitution, your value of activation energy is coming as 43,839.29 joules per mole, which you can always convert into kilojoules. So your final value will be 43.839 kilojoules per mole. Now it is not necessary that you convert it into kilojoules. If you convert, well and good. Otherwise, you can leave your answer in terms of joules if it has not been asked in the question. If they are saying to calculate in terms of kilojoules, then definitely the conversion will be required. Otherwise, it's not required. Then comes the third form. Now in this third form, if we see here, it is a tabular question from 2017, where they have given the concentration of A, concentration of B, and the rate. Now on changing the concentration, the rate is changing. But remember children, for this particular set of reaction, the value of K will remain the same. You have to calculate the overall order of reaction, the rate law, and the rate constant. Now your R is equal to K into A raised to the power X, B raised to the power Y. You will use the values from serial number 1, 2, and 3, and you will form the equations 1, 2, and 3 respectively. We will form simultaneous equation to calculate the value because these values are in power. So to calculate the powers, you have to make the bases same. So for that purpose, we will divide equation 2 by equation 1. In doing so, your value 0.40 raised to the power y will be easily cancelled out because bases are same, so it can be cancelled. The value of K will get cancelled, 10 to the power minus 3 will get cancelled. So you are left with, after simplifying everything, 4 is equal to 2 raised to the power x. As I said, to calculate the power, you have to make the bases same. So 4 can be converted into 2 raised to the power 2 is equal to 2 raised to the power x, because 2 is the base, which is same in both the cases. Therefore, x is equal to 2. Then comes the next part. In the next part, you will choose such two values where the value of concentration of A raised to the power x is same. So we get two values and then we equate, which says dividing equation 3 by equation 1. In doing so, 0.40 divided raised to the power x divided by 0.40 raised to the power x gets easily cancelled because bases are same. Again, 10 to the power minus 3 is getting cancelled from numerator and denominator. Your k gets cancelled. You are left on simplification. 2 raised to the power 1 is equal to 2 raised to the power y. Again, because bases are same, it's 2. Therefore, y is equal to 1. So the first part of your question is solved. Overall order of reaction will be x plus y, which will be 2 plus 1 is equal to 3. Second is rate law. In rate law, you have to simply use the first equation, R is equal to K into concentration of A raised to the power X, where X is 2, so you will write 2. B raised to the power Y is 1, so it will be raised to the power 1. But as the exponent's law says that anything which is raised to the power, if it is 1, then it should not be mentioned. So final equation, or you can say your rate law equation will become R is equal to K into A square into B. The third part is rate constant. Out of the three equations, you can choose any one value and you can equate. On equating, you will get the answer as 71.85 into 10 to the power minus 3 mole per square liter square per second. If you want to cross-check your answer, you use all the three equations to calculate the value of K. You will get the same answer. So I hope this session was fruitful for everyone and it will definitely clear all the doubts for your chemical kinetics. So with this, I will always say, as I say, that please stay tuned with Chemistry Tunes. I will be coming very soon with the next important topic of some other chapter, which is a part of your semester 2 syllabus. Till then, stay safe and just give your 110% in the preparation. This is the time which you are getting to prepare, to master your skills, to learn from your mistakes what you have done. Your pre-board exams might have been conducted or they are going to commence. I hope this session will be fruitful for everyone. Thank you.